Next, derivatives of implicit functions. Derivatives of implicit functions. See, y is equals to f of x is a function. Y is equals to f of x is a function. Then, if y is given as an implicit function of x. Here, this function is called implicit function. So, what is giving? Y is giving an implicit function of variable x, nothing but x, of x, nothing but variable x. For example, you see, x minus y is equals to y is there. So x minus y is equals to y, nothing but y is equal to x minus y. So it is in the form of y is equal to f of x. Y is equal to f of x. So this is x minus y is the implicit function. So what is the variable here? X is the variable. Nothing. So just to remember, if a function we can write as y is equal to some function, then that function is that means y is giving an implicit function. Y is giving an implicit function of which variable? X variable. So this is the definition of implicit function. So mainly you remember the derivatives of inverse trigonometric functions. This one important. The derivatives of inverse trigonometric functions. Already in first we know we have the inverse trigonometric functions and derivatives also we have. Again you remember once derivative of sin inverse of x is 1 by under root of 1 minus x square. Derivative of cos inverse of x is minus 1 by under root of 1 minus x square. Derivative of tan inverse of x is 1 by 1 plus x square. Derivative of cot inverse of x is minus 1 by 1 plus x square. Derivative of secant inverse of x is 1 by x into square root of x square minus 1. Generally we are writing here mod x also. So derivative of cosecant inverse of x is equals to minus 1 by x into square root of x square minus 1. Just so you remember these formulas. You remember these formulas, then easily we are solving next exercise. And for solving the next exercise 5.3, you remind all the formulas in trigonometry. What are they? Sin 2 theta, cos 2 theta, and the relation between sin and cos, tan and secant, cosecant and cot. That means the trigonometric identities, the multiple angle formulas. Multiple angle formulas means 2 theta, 3 theta. So these formulas, once you recall these formulas. See once, sin 2 theta is equals to formula 2 sin theta, cos theta. Cos 2 theta formula cos square theta minus sin square theta, or 2 cos square theta minus 1, or 1 minus 2 sin square theta. Otherwise, if you write tan functions, what you are getting? 1 minus tan square theta by 1 plus tan square theta. Cos 2 theta, sin 2 theta in tan functions, 2 tan theta by 1 plus tan square theta. Next, tan 2 theta. Tan 2 theta formula 2 tan theta by 1 minus tan square theta. So you remember these formulas. And the trigonometric identities. What are the trigonometric identities? Sin square theta plus cos square theta equals to 1. Secant square theta minus tan square theta equals to 1. And cosecant square theta minus cot square theta equals to 1. You remember these trigonometric identities and multiple angle formulas. Why? Because in exercise 5.3, after the substituting, after the simplification, we are finding the derivatives. If we apply the direct formula, it is little bit difficult. So, after the substitution, the given functions we are converted to simplest form, simple form. Later, we are applying the derivatives. Which derivatives we are using here? These inverse trigonometric derivatives we are using. So you remember these formulas also. Then it is easy for next to exercise 5.3.